Okay, so Yamaha XS650. This is a 1980 SG. Today we're going to check the rectifier, make sure it's working okay. Not going to go into a lot of detail in operation here. The rectifier takes your three phases of AC coming out of the alternator, coming off the stator, and it comes out on three white wires and goes up into the harness right here, just behind the down tube. Comes out of the harness back here, and here's a connector where it comes out of the harness, and this is a connector here that runs back to the combined regulator rectifier, which is hard to see. It's mounted to the aft side of the down tube on the frame. Get some of this stuff out of the way right there. And this is a stock 1980 system, still has all the original stuff. So I'm going to pause it for a second, get set up, and we'll check it out. Alright, the rectifier. The rectifier has 6 diodes in it. Full wave rectification, 3 phases of AC. Like I said, I'm not going to go into a lot of detail. Maybe later on we'll do a video covering more detail. Alright, this is going to the combined regulator rectifier. So let's go through this here. The green wire here. The green wire goes to the regulator side of it, and it regulates the amount of current going through the rotor down on the alternator. Black wire here, black wire is the ground, system ground, and the red wire is power feed back to the battery, coming out of the rectifier, going to the battery. Flip it over here. We have a brown wire. Brown wire is system wire from the battery, goes through the ignition switch, a couple of splices, and goes down to the regulator, and this is what the regulator uses to sense battery voltage. It needs to know what the battery voltage is if it's going to regulate it. And here are the 3 wires to the diodes. 3 white wires, so this one goes to 2 diodes, 2 diodes, 2 diodes. Alright, so one diode passes, one blocks on one side of the AC wave, and then it reverses on the other side. So let's get set up here. I made a little jumper wire. We're going to start out on the red wire, battery feed, and we're going to go red to red. And we're going to turn our meter to the diode function. Now you'll notice on the diode function, a lot of people think that this is a resistor function, and it's not. If you look up in the corner here, it says DC volts. So on the diode function, what this meter's doing is it's putting a little bit of power into the system through the red lead and measuring how much voltage is lost going through it. It's looking at a voltage drop. So first thing we want to do is touch our 2 leads together, and we can see we got no voltage drop. That's good. So now we're going to go to each 3 of the white wires, the diodes. We're going to touch one diode, and there's no power going through, current, voltage, however you want to look at it, doesn't really matter at this point. Go to the next one, nothing going through, and we go to the 3rd one, there's nothing going through. So all 3 of these diodes are blocking power going through. So now we're going to reverse the leads, put the black lead on there, and we're going to go to each one, and now the diode's passing power through it. We're getting about a half a volt voltage drop. Next one, same thing, we're losing about a half a volt, and the 3rd one we're losing about a half a volt. So half a volt's pretty typical for a diode in a rectifier system. So now we're going to move our lead over to the black wire, the ground wire, and we're going to check the other 3 diodes. We've got an open, the diode's blocking. Go to the next one, It's open, diode's blocking. Go to the next one, it's open. Okay, so diodes are working in that direction. They're blocking power going through. Reverse our leads, and now we're getting about a little over half a volt voltage drop. It's probably acceptable, a little more than I want to deal with. I'm going to go ahead and make a new rectifier for this, but that would be acceptable. Go to the next one, same thing. Next one, same thing. So a little over half a volt voltage drop. So all 6 diodes are good. They're blocking when they're supposed to, and they're allowing power to go through when they're supposed to. Okay, let me pause it for a second. We're going to do one more thing while we're here. We're going to do this. Some of you guys might have a meter that doesn't have the diode function, voltage drop function. So we're going to switch this over to resistance, ohms. Reading about 0.3 ohms on the meter. And I'm going to show you how to do it on the ohm scale. Ohm scale is not near as accurate for one reason alone. The diodes, we know a diode is supposed to give us about a half a volt voltage drop on the forward bias. What we don't know is how much resistance is in that diode. They vary quite a bit from one diode to the next. So all we can do is we'll look, okay, so that's open, that one's open, that one's open, so they're blocking. Let's switch the leads around. And now we're reading about 1.7 megs or 1.7 million ohms of resistance across that diode. We got no idea if that's what it's supposed to be or not, do we? But what we can do, we'll go to the next one, 1.7, go to the third one, 1.6. So they're all 1.6, 1.7 megs. So what we're faced with is either all 3 of them are bad or all 3 of them are good. The odds are they're good. We're going to take the meter, we're going to go to the negative side, and we're going to test them. That one's blocking, that one's blocking, that one's blocking. Nothing's going through. Switch our leads, and we test again, and we're reading right at 2 megs there, 2.2, and roughly 2.1 megs. So within reason, all 6 of them are reading about the same. The negative side looks like on the negative lead there's probably a little bit of resistance build up in there. So resistance a little higher on the bridge for those 3 diodes. But basically either all 6 are bad or all 6 are good. So we're going to say that all 6 are good because they're reading about the same. If you had one that was way out there, either completely open when it should be reading resistance, or one that was reading 0 ohms that was shorted, then you're going to know it. You're looking for something different. They're all about the same. So you can assume that the diodes are good. Therefore, the rectifier is good. And I'm going to pause it again. Okay, so the last thing we're going to check while we're here is we're going to look at a voltage drop in the system going down to the regulator. As I said, the brown wire to the regulator is there to look at battery voltage so it knows what it is. And it needs to be fairly accurate in order for it to correctly charge. So I've got the meter set up to DC volts. I've got the black lead on the ground, and I'm going to turn the key on. Okay, so now the bike is live, and we're going to go to the harness side, the connector that plugs into the harness, and you can see the red wire right there. We're going to plug the meter into that, and we're reading 12.38. And if I look up the front of the bike, we're reading 12.3 on my cheap Chinese voltmeter, which sometimes is accurate and sometimes isn't, so I don't know what's going on there. But anyway, there's our battery voltage, 12.3. That red wire goes straight back to the battery. What we want to look at is the brown wire. The brown wire, when you turn the key on, the brown wire takes power from the ignition switch and sends it out to various places, ignition system, lots of different places. It also sends it to the regulator. So we're going to plug into the brown wire, and we're reading 12.3. So battery 12.37, power going to the regulator 12.31. So less than 0.1 of a voltage drop, which is good. You want to definitely stay under a half a volt drop, preferably down around 0.2. I'd say not more than 0.3. If you got more of a voltage drop than that, then you got high resistance somewhere. You're losing power. Most likely suspect would probably be the ignition switch. But just thought that since we were here, we'd go ahead and do that. 12.3 battery and 12.3 going to the regulator. So it's looking at good clean battery power as a sensing voltage to know what to regulate to. And that was the only other thing I wanted to show you.